Lesson 4-3, Example 1. Our objective is learning to find the greatest common factor of a set of numbers. And let's say we have factors, a couple of different numbers here, 12 and 18. And I know that the factors of these numbers of 12 are 1, 2, 3, 4, 6, and 12. And I know that the factors of 18 are 1, 2, 3, 6, 9, and 18. Well, some of those factors, 12 and 18, have in common. In other words, the same numbers show up in both lists. And those numbers include 1, 2, 3, and 6. 4 only shows up here, not here. 9 only shows up here, but not here. And same with 12 and 18, they only show up in one place. So I can list the common factors. 1, 2, 3, and 6. So those are the factors that 12 and 18 have in common. The greatest common factor is the largest of these. So this would be the smallest. This number 6 would be the largest or the greatest common factor. So I could say that the greatest common factor, or sometimes it's abbreviated as the GCF, is of 12 and 18. The greatest common factor of 12 and 18 is 6. And this is also one method to be able to find the greatest common factor of two sets of numbers. For example, here we have two other numbers, 28 and 42. And so we can just list all those factors just like we did before. So here we have 28 and we have 42. And for 28, our factors are 1, 2, 4, 7, 14, and 28. And I can even think through and double check, say, okay, that's 28, make a little factor rainbow of those as well. And my factors of 42, 1, 2, 3, 14, 21, and 42. And 1 and 42, 2 and 21, and 3 and 14, another little factor rainbow. And the common ones, what I have in common, the common factors are, well, 1, 2, is 3 a common factor? No. 4 a common factor? No. 7? No. 14 is. 21? No. 28? No. 42? No. So our common factors are 1, 2, and 14. And the largest of those, or the greatest of those, is 14. So I can say that the greatest common factor, or the GCF, of 28 and 42 is 14. So that's one method, just listing out the factors and finding the largest one they have in common. Another method, though, we could use is actually using prime factorization. And here we have three numbers. We have 18, 30, and 24. And I can list out the prime factorization of all three of those. So the prime factorization of 18 is 2 times 3 times 3. 2 times 3 is 6, and 6 times 3 is 18. The prime factorization of 30, 2 times 3 times 5. And the prime factorization of 24 is 2 times 2 times 2 times 3. 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24. So now I can look and see, again, what do they have in common? And I want to look at what they have in common for all three of them. Well, right here I can see they all have a 2 in common. So let's go over it. Do they all have a 3 in common? Well, here's a 3, here's a 3, and oh, here's a 3 too. Or also, I should say. So they have a 3 in common. This 18 also has another 3. Let's see if the other ones do. No, no more 3s here, and no more 3s here. So they do not have another 3 in common. They only have one 3 in common. Let's see though, there's a 5. No 5 here and no 5 here. They do not have that in common. Let's see, they have 2's. 24 has 2 other 2's, but there's no other 2's in the other factor list, so they do not have those in common either. So what I can look here is think, okay, they have a 2 in common, and they have a 3 in common. If I multiply those together, I get 6. And 6 is the greatest common factor of 18, 30, and 24. So I could say the GCF of 18, 30, and 24 is 6. So that's how I can use prime factorization. The final method is is using prime factorization again, but this time looking at it with a ladder diagram. And in this case, we have 45, 18, and 27. And I'm going to set this up in a ladder, but instead of just using it in one, I actually am going to set it up, that ladder, with 3 different numbers. And actually, you know what? I think I'm going to change this number. I'm going to make this a 90. So I'm going to reset up my problem again. 18, 27, and 90. Make my ladder. And now I want to be able to take a common factor from all 3 of these. And a common factor of all 3 of these would be 3, which also is nice because it's a prime number too, and because we're looking for prime factorization. And if I pull a 3 out, I'm left with 6 here, 9 here, and 30 here. So I want to see if I can pull another prime factor out of these 3 numbers. Well, I can take another 3. Here's 2's left, 3 is here, and 10 is there. So can I take out another common factor? Well, let's see. 2 is the only number I could take out of this, but I can't take 2 is not a factor of 3, even though it is a factor of 10. I need to be able to take this factor out of all 3 of these, just like I did in these two. So can I take a 3 out? Well, I can't take it out of 10, and I can't take a factor of 3 out of 2, so that doesn't work. So I'm done. I can't take out any more common factors. So let's look at the factors that I do have. I have a 3 and a 3. Well, if I multiply those together, I end up with 9, and that is the greatest common factor of 18, 27, and 90. So I can say the GCF of 18, 27, and 90 is 9. And if I'm unsure of that, I can use one of the other methods, prime factorization or listing out all the factors, to double check that.